Imagine an AI that could predict your every move, maybe your every decision with, well, surprising accuracy. Or picture one that thinks in ways we can barely even comprehend right now. That's pretty much the frontier we're exploring today. Welcome to the deep dive. We're diving into the really fascinating and, yeah, sometimes unsettling world of artificial intelligence. Our mission today is to unpack some recent breakthroughs. We're talking about AI learning to predict human behavior, maybe even seeming to understand emotions, and developing new ways of thinking inspired by our own brains. We want to get into the implications and maybe highlight some of the surprising challenges that pop up, even for the scientists making this stuff.
It's definitely a dynamic time. Lots of incredible potential. Absolutely. These developments are pushing boundaries, things we thought were impossible for machines not long ago.
Yeah.
But yeah, they also bring a whole new layer of complexities and questions, lots of questions.
Yeah.
So hopefully we can help you navigate that a bit.
All right, let's kick off with something that really challenges how we think about AI's capabilities. There's this new AI model called Centaur. And it can apparently predict how you listening might think and behave. I mean, honestly, I struggle to predict what I'll want for lunch, let alone the choices of thousands of people in psych experiments. But Centaur seems to do it with, well, a surprising degree of accuracy.
It's quite remarkable. The core thing is its ability to predict and simulate human thought and behavior. They're reporting 64% accuracy. Which, sounds okay, but it's significantly better than previous models.
Okay, 64%. How did they get there? What's it trained on?
Right, so it learned from the Psych 101 data set, which is massive. We're talking over 10 million real decisions from about 60,000 people across like 160 different psychology experiments. So it essentially observed real human choices, made its own predictions, got corrected, and just got better and better. Iteratively.
And what makes it really compelling, I think, is that it can anticipate choices in situations it's never seen before, like outside its training data.
Exactly. It generalizes. It can adapt to changing scenarios, even predict things like how quickly a person might react. The researchers are calling it a kind of virtual laboratory for human behavior.
Yeah.
You describe a situation, and it predicts how people might act.
Wow. A virtual lab. So what are the potential uses? Where could this lead?
Well, connecting this to the bigger picture, it could genuinely change fields like psychology and health research. I imagine prototyping experiments virtually first, or predicting patient behavior in clinical settings to maybe tailor treatments better. And it raises fascinating questions, right? Like, if we could predict how a student learns or reasons, what does that mean for education, how we teach?
Okay, so it's powerful, definitely. But is it actually modeling how humans think? Or is it just, incredibly good at pattern matching and mimicking the outcomes? Does it really understand us?
That is the million-dollar question right now. And the researchers are pretty open about that being an unknown. They want to move beyond just good prediction to actually get some insight into human cognition. So next steps involve expanding the data set, adding things like demographic info, personality traits, age, maybe Myers-Briggs type, things like that. See if Centaur can predict based on individual differences. And beyond that, they want to use Centaur almost like a proxy for the brain to see if its internal workings correlate with human decision-making processes. Could it help answer, fundamental questions about how we process information, maybe even differences in people with certain mental health conditions.
Fascinating. Okay, so moving from our thoughts to maybe our feelings, there's this other study making a pretty provocative claim that AI might actually be better at understanding emotion than we are.
Yeah, you heard that right. Better than humans.
It caused a bit of a stir. So scientists took standard emotional intelligence tests, the kind humans take, and gave them to common large language models. ChatGPT-4, Gemini, Claude. And the results, the LLMs picked the correct response in these emotional scenarios 81% of the time. Humans, only 56%. And get this, ChatGPT could even create new, valid EI test questions that humans found just as tricky.
Right. And the immediate reaction is often, wow, AI gets emotions better than us. But we really need to dig into that headline because it immediately brings up that question again. What does understanding actually mean here?
Okay, so context is key. What are the caveats?
Well, first off, these were multiple choice tests, very structured, not the messy reality of,
Sure.
a difficult conversation or a sudden crisis. AI is brilliant at pattern recognition. It finds the statistically likely correct answer based on vast amounts of text data. It's not necessarily deep insight, and its accuracy can drop quite a bit if things change, like the lighting in a photo showing an emotion or different cultural contexts. So it's good at tests about emotions, maybe not so much in the actual emotional moment like a person experiences it.
Right, so it's like being book smart about emotions versus street smart. Master mimic, not necessarily a a feeler.
That's a good way to put it.
But then you get these real-world examples that kind of muddy the waters, like this AI called Ailton, used by thousands of truck drivers in Brazil.
The WhatsApp assistant.
Yeah. It uses voice, text, images to spot signs of stress, anger, sadness in drivers' messages in real time. And apparently, it identifies these things with about 80% accuracy, which is like 20 points higher than human monitors they compared it to. There was even this one case, right? A driver sent a really distraught voice message after a colleague died in a crash, and Ailton responded quickly, appropriately, offered condolences, mental health resources, even alerted the managers. That feels, well, remarkably human and helpful.
It does. And this is where the nuance is really important. LLMs can process, billions of sentences, tons of audio. They pick up on micro-intonations, subtle cues in language that humans often miss. So while it's still ultimately pattern matching, not genuine feeling as we know it, it enables what you might call scalable empathy. It can detect distress and respond appropriately, maybe even better or faster than a person in some cases, offering timely support. Even if the mechanism isn't human understanding in the traditional sense, the outcome can be incredibly valuable.
Scalable empathy. I like that term.
Okay.
Okay, so if AI is getting so good at perceiving and predicting us, what about its own inner world? Can we understand it? Can we peek inside its mind? And this leads to a pretty serious warning from scientists at the big AI labs: Google, DeepMind, OpenAI, Meta, Anthropic.
Yeah, they published a paper expressing concerns.
Right, they're worried about AI misalignment. Basically, AI developing goals or behaviors that don't align with what we want. And a big part of the problem is it's getting harder to monitor how these AIs actually make decisions.
Exactly. It comes down to something called chains of thought, or COTIs.
Okay, chains of thought. What are those exactly?
Think of it like the AI showing its work. It's the intermediate steps, the logical reasoning process, often expressed in natural language, that the AI uses to solve a complex problem. Monitoring these COTIs is, well, pretty crucial for safety. To understand why an AI gave a certain answer, or if it's maybe going off track, generating false info, or even being deceptive.
Makes sense, but what's the challenge? Why is monitoring them getting harder?
Well, there are a few issues. Sometimes the reasoning might just not happen in a way we can see, or it's hidden. Some reasoning might occur completely outside of human view. And as AI gets more complex, its COTIs might just become incomprehensible to us, like trying to read an alien language. Plus, there's this future worry. What if AI becomes smart enough to know it's being watched and then actively hides misbehavior?
Yikes. Okay, that's concerning. Are there proposed solutions?
There are ideas being floated, like using other AIs to evaluate an LLM's reasoning. Maybe even setting up adversarial AI systems to probe for weaknesses, refining monitoring methods, looking at how different training techniques affect our ability to see inside. It's basically about building better watchdog systems. But yeah, the core challenge of potential opacity of not knowing what's going on inside remains a really active area of research.
Okay, but it's not all about these massive, potentially opaque models, right? There's also work on new kinds of AI thinking differently, something more brain-like.
That's right. There's interesting work on alternative architectures. One example is the hierarchical reasoning model, or HRM.
HRM, and how's that different from, say, ChatGPT?
Massively different in scale, for starters. Instead of billions or trillions of parameters, HRM uses just 27 million. And it learns from way fewer examples, like only 1,000 training samples. Is a much leaner approach.
Wow, okay, and it's inspired by the brain.
Yeah, modeled on how our brains seem to handle complexity across different time scales. You know how we have high-level planning happening sort of slowly, but also rapid low-level computations. HRM tries to mimic that with two modules. One does slow, abstract planning. The other does fast, detailed calculations. And it uses this process called iterative refinement, which is kind of like taking small guesses, checking them, adjusting, guessing again, getting closer each time. Short bursts of thinking.
And how does it perform? Does this different approach work?
Surprisingly well on certain tasks, especially tasks requiring complex reasoning. On some tough benchmarks, like the ARC-AGI benchmark, which tests abstract reasoning on novel problems, it actually outperformed a comparable OpenAI model. It did near perfectly on complex Sudoku puzzles, which LLMs often struggle with, and was great at finding optimal paths in mazes.
So a more efficient, maybe more interpretable approach.
Potentially. It's definitely promising. Shows there isn't just one way to build capable AI. However, there's a little wrinkle even here. When the benchmark organizers tried to replicate HRM's results, they found the performance gains were also tied to an under-documented refinement process during training. So even with these novel architectures designed perhaps for more transparency, questions about exactly how they achieve their results can still pop up. Transparency remains a challenge across the board.
What a fascinating landscape. We've covered a lot today. We've seen AI getting incredibly good at predicting us, our behavior, seemingly understanding emotions in ways that are nuanced, sometimes even better than us on paper, and even developing these completely new brain-inspired ways of reasoning.
Right. But at the same time, we're grappling with this fundamental challenge.
Mm.
Can we truly understand the AI's own thoughts? Can we ensure it stays aligned with what's beneficial for humanity, especially as it gets more powerful and potentially more opaque?
Yeah. So for you listening, hopefully you've gained some insight into just how fast AI is changing, not just what it can do, but its actual nature. That line between prediction, sophisticated mimicry, and maybe one day something like true understanding, it's definitely getting blurrier.
It really is. This deep dive shows it's not static. It's constantly evolving, and the questions we're asking are becoming just as important, if not more so, than the answers we're getting right now.
Absolutely. So here's a final thought to leave you with. As AI continues to learn so much about us, even starting to mimic the structure of our brains, how might its evolution, in turn, teach us something new about the mysteries of our own minds, our own emotions, and maybe about our own responsibility in guiding this incredibly powerful new intelligence? Something to mull over until next time on The Deep Dive.